In the two previous videos, we used superposition to find the deflection of point B by keeping one of the loads at a time. Now we are going to solve the last section of the problem, and we are going to find the deflection of point B when we apply the load at C. So the same as previous time. First, we are going to draw our free body diagram. So this is going to be the last section, and the equation we find for this beam is going to be the same as the equation we found for section D, but instead of putting 2/3 of L, we're going to use 1/3 of L. So I'll just write the result for the deflection of B, which is equal to 1/81 times P times L to power 3 divided by E times I. And as we said, the deflection is going to be related to the angle that this beam makes with the horizontal, and that will be equal to CB times theta at point C. And we know that theta at point C is equal to 1/18 times P times L to power 2 divided by EI. And this is also negative. So as a result of these equations, and we know that CB is equal to 1/3 of L, the deflection of point B in this section will be over EI. And as we said in the first video, the summation of the deflections of these three beams at point B has to be equal to 0. So y of B is equal to y of B1 plus y of B2 plus y of B3. And from the previous section, we found that y of B1 is equal to R of B L times to power 3 divided by 3 times EI. And we found that y of B2 is equal to minus 14 divided by A1 P times L to power 3 over EI. And now here, if we look at these equations, we only see that the only unknown here is R of B, and that's exactly what we wanted, because we are going to find the reactions in this beam. So if we add all of these equations together, y of B will be equal to R of B L to power 3 over 3 EI minus 4/81 E times L to power 3 over EI, and minus y of B2, which is equal to and if we solve this equation, we see that R of B is equal to 2/3 of P. So this is our first result. Now if we draw the whole body diagram of the beam with all the forces on it, this is going to be like this: R of B, P, and another load P, and the reactions are fixed. And we're going to have a moment here. Now if we write the summation of forces in the y direction, we see that we have 2p, which are in the same direction and in the negative direction of y, so minus 2p plus r of A plus R of B, which we found is equal to 2/3 of P equal to 0. And this will be equal to R of A is equal to 4/3 of P. And if we write the moments around point A, we can find the amount of MA. So MA is counterclockwise and we assign this positive. So the moment of P is going to be negative since it's clockwise. Minus P times L third minus P times 2/3 of L and plus R of B times F equal to 0. So M of A is going to be 1/3 of PL. So now we found all the reactions that the problem was asking us. And this is R of A, and this is the moment, and we found R of B.